Hi everyone, we have an introduction to limits. We're going to get started on and try to get this concept down a little bit. It's the beginning of a calculus concept, and I was really hoping to give this to you. I was hoping to be able to do this in person, and I don't think we're going to be able to wait that long to get this in, so we're going to have to do it online. And I do have the formal definition of a limit. If f of x, so some function becomes close to a unique number L, it just approaches a certain number as x approaches another certain number, C. We're using L for y and C for the x. From either side, so we'd be coming from the left side or coming from the right side following a function of some kind, the graph of a function. Then the limit of f of x as x approaches c is L. And saying all that, here's the shorthand version of that. So I want you to get familiar with the notation here. LIM for limit as x approaches c of f of x of some function is equal to a value there. So we're going to work on some of that. And first, we're going to look at a basic one. This is a linear function here, 5x minus 3. And what is the limit as x approaches 3? As x gets closer and closer to 3, what does this function, 5x minus 3, get to? Well, it actually will get to an exact value, which we'll see. But let's just fill out the table and just take a look at what's happening here. So if I take 5 times 2.9 minus 3, forgot what I was doing here for a second, I get 11.5 when I fill out this table. And if I put in 2.99 minus 3, I get 11.95. If I put 2.999 in and add another 9 to that, I get 11.9995. I wonder what we're approaching there. I'll bet you've got a guess there. Let's start from the bottom. See, we're approaching 3. Let's approach 3 from the left, from the smaller values of 3, and from the right, from higher values of 3, and work our way down. So let's put in the 3.1. Take those out. And here I'm at 12.5. And put in 3.01. Oops, I forgot what I was doing there for a second. Let me clear that. Let's clear. Okay. There we go. That's what I was looking for. 0.1 minus 3. And I get 12.05. Minus 3, 12 point. Okay, any indications here, what we would get here? Well, 5 times 3 is 15. 15 minus 3 is 12. So as we get closer to 3, we get closer and closer to 12 from the left and from the right. If you look at the graph, now this is equal to 12. If I plot y equals 5x minus 3 and graph that, I got all sorts of stuff on here. I wasn't expecting that. Turn these plots off. Now let's just look at the graph. Oops. Okay. Let's just do it individually. Okay. I can do this. I promise. All right. Now let's look at the graph. Okay. So we're right there. Let me change the window so that I'm only going to go to 5 here. Let's go up to about 30 here and mark it. Whoops.
Okay, I'll do it next time. I gotta get my iPad.
10. Now let's look at that graph. Okay. So if I just kind of trace along here, look at the values of x, 2.2, 8.17. As we go higher, 2.5, 2.6, I'm at 11, 2.87, I'm at 11.36, 2.978, 11.89. When I go past 3, I'm at 12. And if I were to actually put the value when x is 3, you can see when x is 3, y is 12. So we get closer and closer to 12 as x increases toward 3. As x decreases from values above 3 and goes toward 3, we get the y values get closer and closer to 12. That's all that limits are there. All right, so the next thing I want to do is look at this example 2. Now, this one's a little more involved here. It says use a table to estimate the limit numerically. You know how here we could put 3 in, and 5 times 3 is 15 minus 3, which is 12. This one is a different animal because if I put 0 in here, 0 plus 9 is 9. Square root of 9 is 3. 3 minus 3 is 0. I'd have to divide by 0. So it is undefined at 0. But what does it get close to as we get there? So that's what these limits will help us do and explore. It said use a table. This time, let's use the tables that are in the graphing calculator. So, and I would invite you to get your graphing calculator and play along here. But, and I'm also going to change the zoom to zoom standard. Okay. Now, so I'm going to go x divided by, and then I'm going to group here, and I need the square root of x plus 9. Now, that's just for the radical. Then I go minus 3 and then close that. And if I look at the graph, you kind of get an idea of what's happening here. But, and then, you know, what's happening at 0. That's kind of what we want to see. So let's set a table. And let's start from the left side. Let's start like at -2. And let's actually calibrate it by tenths. Okay? On our table. So when I look at the table, you can look at -2, it's 5.6548. -1.9, -1.8, -1.7, and so on. We look at this table that we have here. Okay, I'm getting closer to 0 now. I'm at 5.88, 5.89, almost 5.91, 5.93. At -0.3, I'm at 5.95. -2, I'm at 5.966. -0.1, I'm at 5.988. Now 0, you see we have that error we were talking about. At 0.1, as I come from the other side, 6.08, 6.06, 6.04, 6.03, 6.01, it looks to me, and I'm wondering if you see the same thing, that this limit limit as x approaches 0 of this function is equal to 6. Okay? We cannot put 0 in and figure out the value, but when we look at a table and look at values around, we see that it looks like 6 is what it approaches. And that is an estimate. When you look at, can't do 0, but you're getting close to 6 from that way, you're getting close to 6 from that way. Alright, I'm going to stop this video and we'll go to another example for the next video.